Hey everybody, so it's almost the end of the year, and before the year ends, I kind of wanted to do a video just to show off some of the technologies that I've been working on this year. Um, and I'm going to give one really cool example that I think brings several technologies, which are Pixi, Appose, Napari, all together to help us sort of evaluate how reproducible uh, deep learning segmentation algorithms are. One quick thing I want to mention is reproducibility versus repeatability. So repeatability refers to whether or not the same result can be um, obtained again if the experiment is performed a second time. But with repeatability, you try to get the exact same answer. So you use the same code, use the same images. Basically, you're testing whether you archived everything well enough to be able to do it again and get the same answer at a later date. Exact same answer. Reproducibility is a little more open-ended. It refers to whether or not similar scientific conclusions can be reached when the experiment is performed with similar but not identical data and not identical methods. So in the case of testing reproducibility for deep learning, I think what we're kind of looking at is whether or not different deep learning frameworks or even the same framework with different settings give us similar answers, similar scientific answers. And it's a really, really open-ended question because it you know, different models might be trained for different structures. You might not in many cases want them to be reproducible. But what I sort of am going to focus on right now is these generalist models, which you see these articles come out in Nature and stuff. This new great model. It's the most generalizable, state-of-the-art segmentation method for 8 different microscopy modalities. It finds everything, finds it perfectly. It's great. And then next month another one comes claiming the same thing. So if they're both like finding everything, then they should actually just be giving the same answer. Like they should both be finding everything. And I will go over some ways to test that. So this little video is, it's beyond the scope of this 15-minute video to explain like every single technology that I'm using. They all would require like 2-hour tutorials. But so the first thing I'm going to do is I'm going to use Pixi to start up both an environment and an application. So Pixi is kind of an environment manager. It's really, really powerful. And the cool thing about it is with Pixi, you not only use it to set up environments and stuff, but you can also run like applications with Pixi. And what Pixi will do is it will set up the environment needed for the application, and it'll also start up the application. So I'm going to start up Napari, Napari with a special plugin using Pixi. So I just did that from the command line. And I think one of the ways Pixi might evolve is that people will start making like little Pixi projects that start up like really cool applications, set up all the dependencies for them, and they'll actually, instead of having people jump into the command line like I do, they'll probably just make them shortcuts on the desktop. So anyway, my Napari started up, and then it's going to ask me a couple of things here. I've got this little script that it's going to ask me, this is basically, first thing, parent directory is what images do you want to work with? So I'm going to point to this folder called SOTO. That stands for state of the art. It's just got some images that have been used to train these state-of-the-art segmentation models. I mean, these things are trained on like thousands of images, and this is just a small subset of some of them that like Cellposesam and MicroSam have been trained on. So this SOTO folder is just an image folder. Then the next thing it's going to ask me is select Cellpose3 environment. So this is going to be really cool. So I've got Pixi, projects set up here. I've got two. I've got a Cellposesam one and a Cellpose3 one. And I started up the Cellposesam one. So why is it asking me for a Cellpose3 one too? I will explain that in a little bit. I'm actually going to try to call both Cellpose3 and Cellposesam in the same Napari, but I've got to tell it like what environment to use for Cellpose3. So I've got this Cellpose3 environment set up, and what I have to do is I actually have to give it, the environment is in this folder called default. That's just how Pixi structures things. So I've got to send it this default environment. And then we wait a couple of seconds and the images should load. Okay, cool. So we have Napari up. We have a plugin. This plugin is called Napari Easy Augment Batch DL. I've talked about it a few times in some of my other videos, but basically it's just a plugin to do batch deep learning on collections of images with different frameworks. So you see you have this little selector here where you could choose different frameworks. And we use Napari. So if you know anything about Napari, you know Napari has layers, and you can layers are really useful because you can use them to compare like images and results. So in this case, I have loaded a image layer, and I'm just flashing it on and off, and a labels layer. And the labels layer is actually the ground truths that came with this data set. So I just set them up the right way for my plugin to be able to read them. And I'm looking at images and their ground truths. And I think a couple of ground truths might be missing here, but let's not worry about that. Okay, so some of these ground truths, if you're looking closely, are kind of interesting. One of the quirks of this data set is that there's a few images of blood cells, collections. I think they're red blood cells and white blood cells, which are stained purple. But in almost all these blood cell images for this data set, only the purple stained objects, purple stained blood cells have been labeled. So an interesting thing is that the models that have been trained with this set sometimes have a lot of trouble detecting red blood cells because they weren't labeled in the training data. Then another interesting thing is in some of the images, this is some kind of phase image here, a lot of out of focus structure wasn't labeled. So in this case, there's some sharper structures which are labeled, but then there's a bunch of out of focus stuff which isn't labeled. And this is, and I've noticed with some of these models, MicroSam and Cellposesam, occasionally have trouble with slightly out of focus structure because, and I think it's because of how the training sets were curated. And let's give it a try. So let's predict one of these images. Let's maybe go for this one here. Here's the image. I'm going to go predict. I'm predicting with MicroSam. And we just wait a second here. And it should produce an answer. There we go. Okay, so it's kind of funny. It looks like nothing happened, but something did. It predicted the image, but since MicroSam was trained on this, it looks exactly the same, almost exactly the same as the label. And this is interesting because, like as I mentioned, some of these toolkits don't do that great at detecting the red blood cells because they weren't labeled. Let's try Cellpose. And this is going to be Cellposesam. Let's go predict image. And in this case, Cellpose, interestingly, didn't 100% replicate the label, but it sort of, strangely enough, detected some red blood cells, but not all. And I find that really interesting. I mean, we could speculate that when Cellpose was trained, it saw this image perhaps with no red blood cells labeled. Then it also maybe saw some images where red blood cells or similar looking structure were labeled. So it's kind of learned this pattern like halfway in between, perhaps. Okay, so now a third thing I'm going to do here is In my little frameworks here, I have one called Appose Cellpose Instance Framework. Okay, I just cooked this one up, but it's going to actually call Cellpose3. Um, I I wrote a little plugin to my plugin that's going to use this technology called Appose. So the environment we're in right now uses Cellposesam, but this little guy is going to use it's going to call into a different environment using this Appose magic and do Cellpose3. So and before I do Cellpose3, there's one other thing I want to do here, a little Napari magic, a little Napari trick. So if you're ever working with Napari, any plugin, your plugin, somebody else's plugin, and you want to compare results, go to this thing called duplicate layer. It'll duplicate your layer. Then you can rename it, and I'm going to rename this layer Cellposesam result. And so I have a backup now. So when this predictions gets overridden, when I run a different algorithm, I'll still be able to compare it to the first one I did because I duplicated the layer. And now that I have a backup, let's just do this Appose Cellpose Instance Framework 1. Okay, so we got a result from this, and this is actually calling, like as I mentioned, it's using this Appose magic to call Cellpose3. So now we can compare Cellpose3 to Cellposesam. And we can also compare it to the original label. So you can see that Cellpose3 is detecting red blood cells perfectly. And the older one is actually better in this one case. And again, I speculate that that's because it wasn't trained on this, interestingly, this selectively labeled image. And now let's get the microsam one back too so we can compare all three. So I'm going to do another duplicate layer here. And again, this little duplicate layer trick, you could use it for any Napari plugin when you want to sort of save a result to compare it to another result you're generating. So we'll call this one Cellpose3 result. And then finally, let's go back to microsam and just do the microsam one of this again. Microsam, we'll go to predict image. And there you go. Now we can do all of them. We can go turn them off and on so that we can go here. Let's go labels. These are the original labels. This is microsam. It replicated the label pretty well. Cellpose3 didn't see this label, so it's mostly it is capturing all this red blood cell structure. Cellposesam, it's got about half of them. Somewhere halfway in between. And yeah, that's all we have. Okay, so to summarize, I think these combinations of technologies are so powerful together. So what did we see today? We saw Pixi, which we used to create an environment and start up Napari with a plugin and some images loaded. Then we use Napari itself and its fantastic layer functionality to keep track of results, duplicate them, and compare them, and turn them on and off. And then we also used technology called Appose to run a Cellpose3 in the same Napari instance as a Cellposesam. Yeah, and we're able to start analyzing how these deep learning toolkits work and whether they produce the same result. And in this case, the answer is no. They don't. They produce very different results, even though they're all sort of supposed to be like state-of-the-art structure detection algorithms. So this video, I think that's pretty much it for this video. So I'll just emphasize again, I will put this link. If you get to this repo, it has some instructions, tells you where to get the data, and you should be able to, if you have Pixi on your system, with one command using the command line, you should be able to run this My Pixi project and maybe do what I did. Okay, that's it for today. Thank you.